Hello everyone. Let's start solve today's challenge. Problem number 267. You are given a zero index integer returns and an integer paper. Rearrange numbers such that the following conditions are satisfied. One every element less than 5 should appear before every element greater than 5. If the element equal to 5 chosen between the element less than and greater than the relative order of the elements less than pivot and the elements greater than the pivot is maintained. More formally, this is just basic jargon. Return nouns after the rearrangement. This is the first example given was 9, 12, 5, 10, 20, 3, 10. Pivot is 10. I will take this example and develop our logic accordingly. So let's see how I develop the logic. And this is the example now given to us. This is the edit. This is what? Yeah. 10. So, what we are asked in these questions to keep the pivot elements implemented and elements less than the pivot towards the right of the left of the return and elements greater to pivot elements towards the right of the return. I would just basic approach would be to scan through every element considered and have three lists less than pivot, equal to pivot, and greater than pivot. Initialize them as empty lists. And as and when I iterate through these nums, this is the first index, I would check the value nums of 0, which is 9. And it is less than the pivot value 10. I would add it to the less than pivot value as 9. Then I would iterate towards the first element, which is 12. Again, it is greater than pivot, so it will be inserted here. 5 is less than pivot, so it will be inserted here. 10 is equal to pivot, so it will be 14 is greater than pivot, so here. 3 is less than pivot, so again, here, less than pivot. And this would be equal to pivot, which is 10. Okay, the answer. I would just add these three lists into a result list and return that result list. If nums of I is less than pivot, this would be the body. I would store it in the less than pivot list. If it is equal to pivot, I would store it in this list. And if it is greater than I is greater than pivot, I would store it in this. So this would be our brute force approach. And complexity would be I am scanning nums variables. And complexity equals to of n plus n, which is again its complexity would be of. I think the complexity is getting. So can you avoid taking extra space? Like I'm using this space complexity of what? Can we reduce it down? One. That would be a better approach. So this is our result array which we have to return. It is of the form this and 12 and 14. As you can see, I can just keep a count of less than pivot elements, equal to pivot elements, and then add remaining elements as it is. We would get the index as countless plus count equals to k. So we would get the starting index k from where we have to insert greater than pivot elements present in the number. I would start from 0. J would start from countless. However, number of counts we would get in the first iteration of the nums array, we would just count the um, values of elements less than pivot element and equal to pivot element. So less than pivot element would be 9, 5, and 3. So this count would be 3 countless, and count equals value would be 1 and 1, just 2. So this would be the j value, this would be the k value. Now this is the price voltage what I have shown you. Nums array I have from here. I've got the value of countless and equal from the first equation of the array. I would initialize I to 0, j to countless, and k to this. Countless plus counting, which is 5 p plus 2. I'm initializing them here and move them ahead as soon as I found those values and place it in the result. Afterwards, I would just return result. Excluding this result, I we are Navision space complexity of O. There's also a third way of solving, but it has also the same time and space complexity that the second method of ours. So it's not basically an improvement. Just that we can solve it in this way also. So this would be our result value, which would be initialized with the length of class given to us. To keep it pointers I dash here in the start of the array and result array, and this j dash pointer towards the end of the sorry uh, result list, which would depict all the values more than 50. And using I and j pointers, I would equate over the nums array. I would be at the start, j would be at the end. I would compare these values if this number of I is less than before. I would add it to the I dash and increment I dash and increment I. I would do this towards the whole array, and for j, I would do it backwards to the 0 index. So these values here, our I dash and j dash pointers will reach here at the third and fourth index after filling up all the previous elements. So now, until I dash is greater than j dash, I would insert all the pivot values here. So I dash here 10 would be inserted here. 10 would again be inserted. Now I will implement I dash, decrement j dash. We got the condition of I dash is greater than j dash. So we'll stop here and return this result. Here also the time complexity and space complexity is the same as the previous one. So I'm going to show the coding part for the brute force approach as well as the better approach. I would want you all to write the code for this one on your own and like share it in the comment section so that others also can benefit. Okay, so let's code it up now. I would start with the brute force approach which I showed. So I would make a list of less than pivot elements, equal to pivot elements, as well as greater than pivot elements to store respective elements out of the given nums array. So I would iterate over the nums array using length of nums. Now, if this nums of I is less than my pivot element, I would just append it in less than pivot element list. So fine. Else if nums of items equal to pivot element, I would just append this equal list. Else, this condition is nums of I is greater than pivot, then I would append it in the greater list. Yes. Last, I would add up all these lists and store them in a new result array and return that. Let's run this code. See whether it runs. Yeah, it's passing test cases. Let's see if all test cases are passing. Yeah. Now we would solve it with the better approach, not requiring any extra space. This would be the better approach. I would store in the count less and equal to 10 elements, sorry, equal to 500 elements. Now iterating over. If my nums of x is less than pivot, I would increment count of complex by 1. Else if my nums of x is equal to pivot, I would just increment equal by 1. So now I have the countless and equal values. Now I'm going to initialize my pointers. Store in the result array. I also have to declare the result array. Check the to length of nums. Same size as nums. My J pointer would be at the count place. See the previous 10 minutes of the slide if we IJK pointers as its values. I have explained it there back then. So these will be my pointers. Now again I will iterate over the array. Nums are given to us. Okay, wait. Length of nums is okay. Sorry. If nums of x is less than pivot, I will store it in the result of I as nums of x. I will increment I pointers by 1. L nums of x is equals to pivot result of j would be equal to nums of x. I will increment the j pointer here again. Else result of k would be x. I would also increment j k by 1. At last, I will return the result after populating all the variables at their current places. Time and space complexities are was one respectively. It's passing all the given test cases and it's passed all the hidden test cases as well. So this was it for today. Bye bye. Let's like tomorrow. And tomorrow maybe I will also start up my playlist of Python pieces. So please wait for that playlist. Have a nice day. Bye.